So we're going to be looking at the Term 1 final review. So for the first part, we are talking about the sampling methods. That was our Unit 1. So it says for 1 through 4, you want to see which lunch high school students prefer. All high school students' names are put into 4 groups: freshmen, sophomores, juniors, and seniors. And you select 50 names of freshmen, sophomores, juniors, and seniors from hats. We record which lunch each student chooses from the cafeteria. So the first question is, does this scenario describe an experiment, sample survey, or an observational study? Explain your choice. So since we're not breaking them into 2 groups and comparing one group to the other, it's not an experiment. And since we're not just asking a set of questions, it's not a sample survey, so it has to be an observational study. Because they're just watching. Next question, question 2, says, what is the variable? Remember, the variable is the what. So what did we want to know? Well, we wanted to know which lunch each student chooses. As for the population is the who. So who are we looking at? Well, we're looking at students. Sampling technique. That was simple random, cluster, stratified, convenience, and systematic. Well, since I noticed that they're breaking them into groups, it's either going to be cluster or stratified. Now, since we're pulling people from each group, that's what makes it stratified. For 5 through 7, a toy company develops a new child's toy. The company wants to know if children would prefer the new toy over the current popular toy. 100 children who have typically played with toy company's current popular toy were chosen and given both toys. The proportion of children playing with the new toy versus the current toy was recorded. So the control in this experiment. Remember, the control is the thing that we don't mess with. It's the thing that we're testing something against. Since we're testing the new toy over the current popular toy, that means the control would have to be the current popular toy. Now, there are multiple issues that could arise from this. So this is what just an example. So since the children already have played with the current popular toy, they are more likely to play with the new toy as they already know what the other toy is. So 7 is design a process that would remove any bias in it. So how could we do this without the bias that we stated? Well, once again, this is just an example. We could say, give each child one toy for an hour to play with, then give them the other toy for an hour. Then ask them which toy they prefer. Ken wants to find out how many hours per week high schoolers in his high school district are doing their online work each week. So design a process for taking a sample that would represent the population. So this is using any of our sampling methods. So this is just an example. We could choose, so sort every student alphabetically, then choose every fifth name. Call home to those families and ask, does your child do their online work? Now we're on Unit 2. Unit 2 is all about displays. So, to determine if a set of numbers is random or chosen, mathematicians see if there are any clusters or grouping of numbers to see if there are any patterns. So these were a set of numbers. Create a display of your choice to represent the word length. Now, here's the thing. You can choose any of the display methods. So you can do a dot plot, you could do a box plot, you could do a histogram. What I'm going to do is I'm going to do a box plot. It does not matter. So I type the numbers in my calculator, and I need to make a number line. So my number line has to go from the smallest number to the biggest number. So in this case, 0 to 11. Then I need to put the hash mark above our minimum, which was 0, our Q1, which was 2, median, which was Q3, which was 3, Q3, which is 8, and maximum, which was 11. To make the box, we combine Q1 to Q3, then draw in our whiskers. So that gives us some ideas of how we're going to have to answer our next question. Next question says, describe the distribution in terms of shape, center, and spread in context of the situation. Then determine if there are any outliers in the data set. So when we talk about shape, we're talking about distribution. And in reality, the main types that we have are mound or normal, skewed left, skewed right. Now, looking at this problem, I notice that my median is far off to the left. So what that tells me is the graph starts off small and then slides down to the right. That means that this is actually a mound shape, not mound shape, a skewed. In fact, this one is skewed right. Center, especially for a dot plot and a box plot, is our median. Well, fortunately, we found out what our median is. Our median is 3. That came from our calculator. Spread refers to range. So in this case, biggest minus smallest, so 11 minus 0, which is 11. Now, outliers. We need to find our interquartile range, or our IQR. So in this case, it's Q3 minus Q1.
Can I have a custodian to the main office?
So in this case, our Q3 is 8. Our Q1 is 2. So 8 minus 2 equals 6. So what we're going to do with that 6 is we're going to take that times 1.5. Remember, it's always going to be your IQR times 1.5. So in this case, 6 times 1.5 gets us 9. So there are two things we're going to do. We're going to take our Q1, which was the 2, and we're going to subtract the number that we found, 9. Doing so, we get negative 7. So, look at our numbers. We have no numbers smaller, so we have no lower outlier. Then we're going to take our Q3, just the 8, and we're going to add that 9 to get 17, which means that we have no upper. Meaning we have no outliers. For the next problem, number 3, the histogram to the right gives the monthly salary of the United States from 1944 to 2005. Which measure of center would be more appropriate to report for this data? Define your choice. Now, this is a histogram, so we need to figure out what type of distribution. If it is uniform or mound shape, does not matter which one we choose, mean or median. If it's bimodal, has to be your median. If it's skewed left or skewed right, it also has to be your median. Well, looking at this problem, I noticed that the majority of the data is on the left, and it slides down to the right. So it does that thing, meaning it has to be median. Median would be the best choice because our graph is skewed right. Mean gets pulled to the right, so only the median is in the middle. For 4, test scores of Unit 1 assessment for 2 classes are shown in the following data plot for a class of 24 students. Each quiz has a maximum possible score of 100. Dot plots of the data are shown. Compare the distributions of the 2 classes using shape, center, and spread. So once again, shape is our distribution. So, looking at our 2 classes, class 1 has the majority of the data on the left, and it kind of slides down to the right, so that means class 1 is skewed right. Whereas class 2 kind of balanced, with the majority in the middle, balanced on both sides, so class 2 is mound shape or normal. Center. Center for a dot plot is a median, meaning we need to find the median. So median is the middle number. There are 25 numbers. Half of 25 is well, 12.5, so we want to find the 13th number. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that means for our center for class 1 has a median of 88. And class 2 has a median, well, we need to count to 13 again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So they have a median of 90. Spread, remember, is our range. So class 1 has a range of, well, their biggest number is 98, smallest number is 82. 98 minus 82 gives us 16. Whereas class 2 has a range of, their biggest number is 100, smallest is 81. So 100 minus 81 gets us 19. Now we're on Unit 3. Unit 3 was scatter plots. So it says a probability and statistics teacher was curious about the correlation between a student's amount of time they work on their online material and the grade they receive on an upcoming assessment. They selected 10 students and had them record the number of hours they worked on the material at home and the score they got on their assessments. So just looking, I kind of want to know before we even start what my explanatory variable is and what my response, aka my x and y. Since we have time, we're thinking that time working on a line affects our grade. So that means time should be our x and our grade should be our y. So describe the direction, form, and strength of the scatter plot. Now you could type the numbers in the calculator. You'll probably have to do that. But just looking at it, I noticed that they make it's going up from left to right. So that means it has to be positive. And the dots are really close together in making a line. So I wanted to say that this is strong. The farther apart they are, remember, the weaker it gets. And it's pretty close to making a line, so I can say linear. Now, number 2 says, using the residual plot, justify why a linear model is appropriate for the data. So remember, for a residual plot, the points need to be kind of all around that zero line, that x-axis. There's not any patterns, and they're not all above it or all below it or a majority above or below. Looking at our residual plot, I noticed that there really is no pattern to this. So we don't have an exponential curve or a quadratic arc. None of that is happening. Also, there's a fair mix above and below. So, since there is no pattern, and the dots are equally spread, across the x-axis, a residual plot would, the residual plot shows that a linear model would be accurate. So then 3. 3 says write an equation of the least squares regression line. So we're going to need to type our numbers into our calculator. So remember, when we type the numbers in, we need to put the x's in L1, y's in L2, and then go over and choose stat over number 4. Now, according to our calculator, we end up getting 4 things. Gives us our A, our B, our R squared, and our R. So the equation of the least squares regression line will be y hat equals AX, so in this case, 7.449 x plus our B, which is 57.26 . Now for the explanation of our slope, that is the thing where we need to use that base form that I gave her for 1. So the explanation of the slope would be as our explanatory variable. So in this case, as the time working online increases by 1, our response variable, or our grade, changes by our A, which was at 7.449. To explain the y-intercept, or our initial value, that is our B, so we would say we started with B, or in this case, 57.26 as our grade. Now in 6, it wants us to find that correlation coefficient and interpret this value. So that is our R. So R equals 0.8838, blah, blah, blah. So then looking at our number line, that tells us that it is a strong, positive, linear relationship. Seven, the Iowa Department of Agriculture kept track of crop yields in the average summer temperatures. What is the best function that models this data based on the patterns in the scatter plot? Now looking at it, it does not make a nice solid line. It does not make a curve, so exponential. It makes an arc. So that tells us that it is a quadratic. So it makes a capital U. In this case, it's an upside down capital U. Last bit. For high school students, there's approximately a linear relationship between how long someone studies, ranging from 0 to 5 hours, for a test and their score on that final. The relationship can be represented by y hat equals 64.5 plus 5.5x, where y represents projected score and x represents hours studied. So Sarah studied for 2.5 hours. What is her predicted score? So that means we need to plug that 2.5 in for x. So in your calculator, you would type in 64.5 plus 5.5 times the 2.5, and we get 78.25. So then she was curious and decided to study for 6 hours. So using the equation, we predict that Sarah would get a 97.5% if she studied for 6 hours. Is this an accurate prediction? Now, we did use the equation, however, this is not accurate. Since the equation is based on 0 to 5 hours, and 6 hours is outside of that range, that means this is an extrapolation, which is never accurate. So then, based on this data, is it reasonable to conclude that time studying is responsible for test scores? Explain. So we could assume that the more you study, the better you do. However, if you study the incorrect material, your score won't go up. So here's the thing. Just because there is a correlation, so no. Just because there is a correlation between two things, it does not mean that one makes the other happen.